this summer we heard about catfish irrigation management technique, and that's where you just throw a catfish out there in the field and try to keep him alive. And I was in some fields this summer where I think that's what they were doing. But today I would like to introduce you to a different management solution, and we're calling it the Aqua Planner. Okay, when we're talking about irrigation management, what we're talking about is managing the soil water content so that yield and our net profit is maximized given the total the available water resources. And you can only manage the soil moisture when you know what you have and you have an expectation of the future conditions or the future requirements. And the Aqua Planner is a forward-looking tool for managing soil moisture. What it does, we maintain the current, keep track of the current water balance. We anticipate the future requirements of the crop, and it considers the water production capability available, how much water you can pump, and makes recommendations in order to meet that management objective. And it's based on old science. The research has been ongoing since the 50s. We just incorporated some new technologies, and hopefully we put together a user-friendly, web-based application that's a useful tool for ag producers. And soil moisture modeling was endorsed by major universities as a preferred irrigation management. You can do a Google query on irrigation management or soil moisture modeling, and you can find a lot of interesting work that's been done. The Aqua Planner represents the entire field, and and not just a particular point in the field. It represents the entire field, and it indicates the current soil moisture levels, and it projects the future requirements for that field. And it does all this taking into consideration what your sprinkler capacity is, and depends on and it develops an irrigation plan based on these conditions. And what it does, we set some objectives out there, like for instance on corn, we might like to have the soil profile full at 10-leaf stage, have the profile full at silking, and we'd like to keep it maybe 75% full at dent, and then have it tapered off to where it's right at the stress level when it reaches the black layer. And the Aqua Planner does all this for you. And it can be totally automatic. We're set up to with pivot track monitoring service, and we'll know when your sprinkler is running. We pick up radar estimated rainfall, so we know how much rainfall you've received on that field, and we keep track of the ET, and it's all automatic. And it's web-based reporting. Hopefully we've got a user-friendly website, and we also send out daily emails and text messages, and we've also formatted it up so it's available on our smartphones and stuff. Okay, the data inputs into the system are the initial soil moisture content for the field at planting time, and then we keep track of precipitation, and we keep track of applied rain irrigation, and then the daily ET. it's just a simple water balance method, and it's just kind of like your wife's checkbook. You know, you put in some money and keep track of how much she spends at the shoe shop and the dress store, and then just try to keep it up above the zero line. But that's all we're doing. We're just keeping track of the soil moisture balance. The Aqua Planner projects the future water requirements. We have a historical database of what the evapotranspiration has been, and we can project that, so we can use that and project it in the future. We also make a ET forecast for the next 8 days based on temperature forecast for the next 8 days. We also report on our website what the precipitation forecasts are. We haven't yet incorporated that precipitation forecast in our model, but we're thinking about that. I think, and just kind of review some of the stuff that Dave's already talked about on the agronomy. You know, we've got our soil profile, and we you know, if we had a bucket of water or a block of water, a block of soil, and we were to fill that block completely full to where all the air spaces, all the air was forced out, we'd be at what we call saturation. Then if we pulled the plug out of the bottom of that and let all the water drain out of it that would, we'd be down to what we call field capacity. And the water at that level is maintained, is held in the soil by capillary attraction. And that water can freely move in the soil by capillary attraction. And if we was to plant a corn plant in that bucket, it would pull the water down until it got to the wilting point. And at that point, the water can no longer move by capillary action. It's held so tightly by the soil particles. There's still water there, and if we dried it in the oven, we could go ahead and dry it down. But this area right in here is what we call plant available water. But only about half of that is readily available. It depends on the soil type and the crop. But right at the management readily available water, that we call that the management allowable depletion. And so the idea of our soil moisture management is to keep it in the green. You know, we want to keep it in the green. If we get up here in the blue, we get in that saturation, and it inhibits root growth. Roots have to have oxygen. We get to they can't breathe, and it inhibits root growth. And if we get down here in the red, then we start experiencing yield reducing stress.